Um, yes, all right. So let me talk about Parkinson's disease first. Since last week, we discussed some of the neurological disorders, and Parkinson's disease is one of them. So Parkinson's disease is a neurodegenerative disease, which means that slowly and gradually the brain is, and parts of the brain are dying or deteriorating. And then especially the part in the brain, which is called the midbrain. And in the midbrain, you will find the basal ganglia. And this is like a group of tissues surrounding the middle part of the brain. And the function of those basal ganglia is mostly within the motor system. So it really helps us in our movement, the involuntary movements, but I believe also some parts are related to the voluntary movements. Within the basal ganglia, there is a group of tissues which is called substantia nigra, which means actually black substance. And then there's a part of that which is called pars compacta, so a very compact part. And within that part, apparently in Parkinson's disease, neurons or the brain cells are dying gradually or slowly. There's a certain type of protein involved in all of this, and it's called alpha-synuclein. I don't think you have to remember that name, but it's a protein, and this protein becomes misfolded. So instead of developing properly or being synthesized properly, it is synthesized in a wrong way, and it's misfolding itself, and then they clump together with other similar proteins, and this causes cell death within the brain. So apparently some cells within our neurosystem or within the brain are not able to remove those clumps or clusters of proteins. And then they become cytotoxic. So they are becoming toxic for the brain cells. And this is damaging the cells, which lead to the cell death. So because the part in the brain which is affected is very much related to movement, in Parkinson's disease, you see a lot of motor dysfunctioning, like rigidity. Let me see, there are some other very symptomatic signs of Parkinson's disease. So yeah, I think it's good to know where in the brain this is. So let me share with you the brain. So I can show you the midbrain and the basal ganglia. But let me see. Oh yeah, there's one thing I would like to explain also about the brain cells. Because when we look at nerve or neurons, those are considered the main brain cells within our neurosystem. But there are other cells, they are called glial cells, and they support the nerve cells in their functioning. So if you have one nerve cell, actually you have about 10 of those supporting cells that help your nerve tissue to function properly. So those glial cells are actually much more higher in number, and there are different types. Some of them produce the sort of white substance that makes the electrical impulse travel faster. Other of those glial cells bring the nutrients to the nerve cells because there's no direct contact with blood. And there are some of those glial cells that act as defense mechanism. So they are sort of immune cells. So yeah, it's important to know of them. And apparently there's an imbalance in the types of glial cells also present in Parkinson's disease. So yeah, let me see if I can share with you the screen. This one. So actually what you're seeing now is quite familiar. I think we've seen this sort of image also in Complete Anatomy. I can turn off all the blood vessels, cardiovascular. I can turn off respiratory, so we will just see the nervous system. And the eyes are still present. So, of course, this is the front part of the brain that we're looking at. So here you see the middle part of the brainstem. This is the pons. And above the pons, let me see where it is. There's some structures hiding it. Okay. Well, above the pons, you actually have the midbrain. So let me see if we can search for that. Temporal lobe is gone now, so we can see the structures behind it. And then you see the brainstem. Here we see the pons again. This is the medulla oblongata. Above it is the pons. And then there is the midbrain. So you can see even the projection, and that is bigger than the part that we can see right now. And in the midbrain, you have those basal ganglia. So somewhere there, we find also the substantia nigra, which is affected in Parkinson's disease. But this should be a healthy brain. And I think they can do like imaging on the brain, actually to make sure that it's not a different type of disease. So if they want to diagnose Parkinson's disease, they don't really have imaging for it, but they do make images to make sure it's not one of the other diseases that it could be. So in this table, I couldn't find a case that's showing Parkinson's disease in the brain. Let's see, we can also remove the temporal lobe on that side. So then we have better view. Maybe nice to know. Mammillary body there. Amygdala, these are all typical structures of the midbrain, and yeah, very typical structures that you can find there. Yes, I can show some images on the table here. I couldn't go more in the details of the midbrain, unfortunately, but I found some nice images on website as well. So maybe we can combine all of that information. So let me share the table first. But what I'm going to show you now is a slide through a whole head, actually, like this. So we'll look from the side through the head, and it's a real image. So if you don't feel comfortable with that, it's maybe good to look away. Just to make sure that no one will see something that they don't want to see. Right, so I'll give you some time to make a choice. Sorry?
The graphic?
Yeah, kind of. But there's some colors because I selected some structures already. So, but yeah, so here we go. So yeah, this is actually what you would see when you would do a dissection. This is the colors that the tissue will have after the death of the body. But I selected some structures that obviously have an artificial color. So you will see the medulla oblongata in violet or purple. Then in yellow, you see the pons, and in green, the midbrain. So the substantia nigra is within the midbrain. It's a part of the midbrain. And then the basal ganglia are on top of the midbrain and surrounding it. So I just also posted in the chat that the substantia nigra supplies the dopamine for the basal ganglia. And in Parkinson's disease, the substantia nigra is affected, so the dopamine supply is affected as well.
Dopamine level goes down.
Sorry, what did you say?
No, I was just curious if you could explain to us the decrease in dopamine supply does what to the brain and to the body.
Yeah, well, so dopamine is for the brain is a neurotransmitter. This means it helps the electrical signal travel from one nerve cell to the other. And then when it is affecting the supply of it to the basal ganglia, it means that there's an effect on the motor system. And that's why you see in Parkinson's disease, the tremors and the rigidity, slow movements. Is related to the lowered supply of dopamine, I guess, and the lowered amount of, yeah, neurotransmission, actually. So there's some other images I could show you. I'm going to share from my laptop screen. So here I'll show you some dopamine pathways. So here again we look at the we call it a sagittal view of the brain. So this is the front. Here we see the pituitary gland, and this is the back. And then here you see the substantia nigra in the midbrain. So this is the midbrain, this is the pons, medulla oblongata, and then the spinal cord here. So the substantia nigra, you can see the pathway of dopamine to these areas. So the putamen, which is part of the basal ganglia, and this part as well, the dorsal striatum. Then you see there's also other parts of the brain that supply dopamine and the pathways of it, the blue structures. So I guess that is quite interesting. Let me see if I can also go to the other ones. So here we'll see a rotating model of the substantia nigra in red. Do you see that? Do you see the brain rotating now? Okay. So you see the red part here is the substantia nigra, and this is the midbrain area. So here again we see the pons, and this is the medulla oblongata. So this is the whole brainstem, and the red part is the substantia nigra. So it's quite at the sides of the midbrain. And then there's another image here of the basal ganglia. So all the red structures. You see here indicated the red is basal ganglia and the blue are related structures. So then here again you see the substantia nigra within the midbrain, and then above you see there's quite a lot of structures of the basal ganglia actually higher than the midbrain.